Hmm. So in the last lecture, what we have derived, we have derived four parameters, and the last parameter that we have derived is output impedance. See, output impedance also we have finished with. Is it? Now let me tell you that if this is what four parameters that we have derived amplifiers parameter for transistorized hybrid module. And in every parameter, that is in input impedance, in output impedance, or the current gain or the voltage gain, all those four parameters we have derived. And if you observe the equation, then one thing that we can conclude is all those parameters, all those amplifiers parameter are actually depend on H parameters, is it? बस सभी जो कंपोनेंट है AI, AV, RI, RO, वो सब किस पे डिपेंड करते हैं? हाइब्रिड मॉडल पे, हाइब्रिड पैरामीटर पे. सी इवन इफ यू चेक द लास्ट इक्वेशन, where's the pen? If you check the last equation, then where is pad? Okay, there it is. If you check this equation, look at this equation. Output admittance, output admittance is depend on what? It is depend on HO, HF, HR, HI. It means every parameter is directly or indirectly, it is depend on hybrid parameter or hybrid model, is it? But we know that hybrid parameters are not faithful. We can't trust them fully. We can't trust HF, we can't trust HO, we can't trust HI. Those four parameters, HO, HF, HR, HI, we can't trust them fully. See what I'm saying? I have derived those, is it? I have derived those with the help of two-port module, and now I am saying I can't trust them. Is it? Yes, I cannot trust them. Let me tell you an example. Right? Think about HF. Think about that HFE parameter or beta. Generally, if I'm in AC analysis, I will write HFE. If I'm analyzing common emitter configuration in DC scenario, then I supposed to use beta. So those hybrid parameters, what's the conclusion? See, after deriving four parameters, four amplifier parameters, I have a conclusion that input impedance, output impedance, current gain, voltage gain, those parameters are depend on H module. Those parameters are depend on hybrid parameters. Is it? But hybrid parameters itself are not trustworthy. उन पे भरोसा नहीं कर सकते हम लोग. We can't trust them. Why? Because see, you go to the lab. You go to the lab and take one transistor. Is it? Take one general purpose, a black body transistor. Is it? Take a transistor BC547. A general purpose, easily available transistor in our lab. Is it? And one thing we know that if for a practical transistor, I can measure its HFE, that is beta, with the help of multimeter. Multimeter. It means I can use multimeter to measure the H parameter. What is this H parameter? HFE, or what I can say, it is a beta DC. Okay, let me write small as DC. मल्टीमीटर का यूज करके हम लोग HFE और बीटा DC फाइंड आउट कर सकते हैं. यस, इजीली. टेक अ ट्रांजिस्टर, take a multimeter and insert this transistor into the slots provided to the multimeter, and your multimeter display will clearly shows the value of beta for this transistor. Is it? The transistor that I have taken is BC547. So if I take same transistor BC547, then its HFE is showing 330. For example, मैंने लिया, मैंने चेक किया, मुझे 330 वैल्यू दिखा रहा है. Second time, what I have done, now I kept this transistor aside, I have taken another BC547. See, I am taking another transistor with same fabrication, same module, same company, same BC547. See, I have taken same BC547, and now I am inserting that BC547, the second one, into the multimeter slot, and I am checking HFE or beta. This time it shows only 310. Yes, the value is different. Even if the transistors are same, the HFE value is different. Now, consider a third case. You gave the multimeter to your friend. Take my transistor with me. I have two transistors. One shows 330 HFE, another shows 310 HFE. You told your friend that take another BC547 and measure HFE. Then your friend took another BC547 and he started measuring HFE. Now this time this multimeter shows 290. You repeat the process, taken another BC547 and measure HFE. Now it is showing 360. You take another one BC547, measure HFE. Now this is showing 350. Look at the value. Whether value is same every time. It means even if the transistor is same everywhere, it is BC547, 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 BC547. Every time I am taking BC547 transistor, but still HFE is different. Is it? It means those H parameters itself are not constant. Is it? वो खुद से ही कॉन्स्टंट नहीं है, स्वतःमध्येच कॉन्स्टंट नाही आहेत ते. हाऊ कॅन वी ट्रस्ट देम? इज इट? ते स्वतःमध्येच कॉन्स्टंट नाही आहे. सी वी हॅव टेकन इट. यू कॅन डू इट इन लॅब. गो टू द लॅब, पिक अप रॅन्डम ट्रान्झिस्टर, measure HFE, you will get different value. Take another with the same model, you will get different HFE. Like this, those H parameters itself are not trustworthy. They are not itself constant. खुद में ही constant नहीं है वो, खुद से ही कितने variation दिखा रहा है. So obviously we cannot trust them. Is it? अगर हम HFE is not constant, obviously the equations where I am using that HFE will get changed. I'll get different values for RI, I'll get different values for RI, RO, AV, AI. Is it? So H parameter वो खुद से ही constant नहीं है, तो उनको हम किसी और equation में use करेंगे, so obviously we'll get different value. And that's why practically we need to find some other solution. And what is the solution? The solution is approximate H module. The solution is approximate H module. This is a solution. Even this is not a full solution, but it is a method to tackle that variation belongs to H parameters. Is it? समझ में आ रहा है? Yes, it is approximate H module. Now let's start with what is that approximate H module. We know H module. What is H module? Here somewhere I am applying input. This is what my HI. This is HR multiplied by V2. And this is output current. Here somewhere output impedance. Okay, show the correct here. It is HI. This is voltage. I will write HR multiplied by V2. This is current source. I will write HF multiplied by I1, and this is 1 divided by HO. This is actual hybrid model. Now what is approximate? मतलब this model को हम लोग approximate कर देंगे. Why I am doing approximate? Because practically मुझे use करना है. Practically अगर मैं exact model जो हमने derive किया है अभी वो use किया, practically if I use this model then values will become wrong. Why? Because H parameter itself are not stable. So that's why I will process something. Now what is the process I will do? If there is, if, that is the most important word that I need to use. If approximate, exact H module को approximate में convert करने के लिए this if is really important. Now see, if the value of load that I have connected, for example, if this is the hybrid model and I have connected one load resistor RL, and if this RL is very less than the value of output impedance, अगर ऐसा हो गया, if the value of load resistor that I have connected is very less than the output impedance, that is 1 divided by HO. It is output impedance of hybrid module, 1 divided by HO. Is it? Actually, output impedance, we have derived a different notation for that. We said it is RO. And what is that RO? It is 1 divided by YO. What is that YO? It is in the form of HF, HR, HI, HO. Yes, it is. So what is that 1 divided by HO? It is output impedance of that H module only. Understand that? So now, this, if RL is less, now look at this, less, this value is small. The small value is in parallel with the large value. Remember network analysis thumb rule. If a large value of resistance is in parallel with small value of resistance, then what will be the equivalent impedance? Equivalent resistance will be approximately small value of resistance. Is it? So it means if 1 divided by HO and RL, they are in parallel, and when RL value is very small, then this 1 divided by HO, this value has to be neglected. Why? Because इनका parallel combination क्या आएगा? RL ही आएगा. Why RL? Because RL is very small. Look at this. So that's why I said if is very important. So if RL is very less than 1 divided by HO, then this 1 divided by HO has to be neglected. वो रहेगा ही नहीं क्योंकि उसका value बहुत ज़्यादा है. Large value of resistance is in parallel with small value of resistance. Equivalent is always a small value of resistance. So बचेगा क्या? Only RL. Is it? So this is about output part. Come to the input part. Now, what happens at the input side? Now, at the input side, look at this. RL is very small. This RL is very small. So if the load resistance across which I am measuring V2, that is output voltage, is it? Output voltage is the voltage across RL, and RL itself is very small. It means output voltage is equals to what? V is equals to output current multiplied by output resistance. But this output resistance is very small. Then obviously this value VO will be very small. Why I am writing VO? I have to write V2. I am sorry, then it's my mistake. Try to. It is my mistake. It is V2. So V2 is equals to what? V2 is actually VO. I know that. So V2 is equals to I2 multiplied by RL. But RL is very small. So the product I2 multiplied by RL will be very small. It means this V2 will be very small. Is it? So as if V2 is very small, it means HR V2, this product will be very small. It means this voltage that I am talking about, this voltage will be very small. It is so small as if I can consider it as a short circuit. It means now this will become a short circuit. So voltage has to be replaced with a short circuit. तो उसको भी हमें क्या करना चाहिए? Neglect. So this has to be neglected. See, only one condition. If RL is very small, अगर आप very small, एकदम छोटा सा लोड अगर आप कनेक्ट कर रहे हो, लोड मीन्स आई एम टॉकिंग अबाउट द रेजिस्टेंस, राइट? अगर आपका लोड रेजिस्टेंस एकदम छोटा है फॉर दिस हाइब्रिड मॉड्यूल, then it will get converted into approximate H module. So what is approximate H module? If RL is very less than 1 divided by HO. Now see, I have to neglect 1 divided by HO, I have to neglect HR V2, then what is the remaining thing? बचा क्या फिर? What I left with? I left with only this thing. I left with HI, this HR V2 replaced with a short circuit. I left with a current source. What is the current source? It is HF. That's what. So this is, if I say this is V2, this is V2, then I need to say that this, what happened? This, okay, this is my, sorry, it's my mistake. I'm sorry. Okay, forget to draw the box, but I will draw. Yes, now this is what my approximate module. Is it? What is approximate H module? When load resistance is very small. Is it? Load resistance is small. Load resistance small. It means load current is high. It means now I can use this module practically. Now this module can handle large current. This module represents a very small load resistance. So that's why this module can be used at the practical design, is it? So henceforth, whenever we start with amplifier design, we will use that approximate H module always, is it? If you want to, you can connect a small resistance, is it? Resistance is small, so this is RL. So इसको क्या बोलते हैं? Approximate H module, is it? So henceforth, in the whole chapter, we are going to use approximate H module to analyze amplifier. See, whenever I say amplifier, you need to remember that I am talking about common emitter amplifier, CE. Common emitter. It gives good voltage, good current. So that's why I use common emitter configuration. So henceforth, it will be common emitter amplifier, and going to common emitter amplifier with the help of approximate H module, not with the exact. So whatever previously we have studied is an exact H module. Now what I have derived is approximate H module. So henceforth, let us use approximate H module. Now as we have derived this approximate H module, apply this to C amplifier. Let us start with.